So the first one, make sure you have your name and last name on both, right? The first one is just a basic graph. I'm looking at it, and it should probably have arrowheads on the wings as well. So you should have income in dollars. You have your mean in the middle. You go up by 15,000, you go down by 15,000. You have your z-scores as well. And so now we can start answering. So 3 marks if everything is there, including labels, right? So you need the percentages in there within the sections. Okay, if you were to use normal CDF and say how many households would be making between 45 and 60,000, this is your lower, your upper, you would get approximately 34%. Okay, normal CDF is a little bit more specific. We're estimating, these percentages are estimations, right? So you have 16% for 16% makes 60,000 or more, because 60,000 is right here. So you just add up these 3 sections. That's what I mean by showing work. This is probably a good idea to show me what you've done. How did you get that number? What percentage of households have an income between 30 and 90, right? So between 30 right here and 90. So I don't know if you want to add 68, 13.5, 2.35, but it ends up being 83.85%. Winnipeg consists of 200,000 households. How many households earn less than 30,000? So now it's how many, not what's the likelihood, what's the proportion or percentage. So 16% earn less than 30,000. That's based on my graph. So you just go 0.16 times 200,000. So it's 32,000 households. So you get 1 mark for having the 16% somewhere, and another mark for coming up with the 32,000 households. What's the z-score of an income of 20,000? Just use your formula, and it's actually minus negative 1.67, which makes sense, because if your average is 45,000, 20,000 is below the average, so it should be negative. Calculate the income with a z-score of 2.24. So you use this formula, and you get 78,600. Okay. So there you have it. So nine marks for this page if you add up everything. And let's go to the back side. And so we are comparing to Toronto here. And I just make a quick note that Winnipeg has a mean, right? This is the mean for Winnipeg, and this is the standard deviation in terms of the salaries or incomes, right? So I compare it now to 60,000 in Toronto, 25,000 in for the standard deviation in Toronto. So you're comparing it. So if Winnipeg is the solid line, right, the center of the curve is what the mean determines that. Where is the center of the curve located? So for Toronto, it should be higher up along the x-axis. So there it is. So somewhere in here, just look at my pencil, I would be saying this is the middle of my curve, right? For Toronto. I don't know how steep it's going to be yet. This is the center of the curve for Winnipeg. That's what the mean tells you, right? And then the standard deviation will tell us which one should be steeper. Okay, so Toronto has 25,000, so it's flatter. Okay, Toronto higher standard deviation, right? Flatter, spread out, varies, more variation, right? That's what a higher standard deviation tells us. It's still the same. Was still true at the beginning. It's still true now, right? Winnipeg, right? Lower standard deviation, steeper curve, more clustered around the mean, right? These points for Toronto are a bit further away from the mean on average, right? So there's more consistency, right? So how about, you can't hear this enough, right? Steeper. The graph will be steeper, clustered around the mean, consistent. I would say more consistent, right? More consistent. So there you go. That's what it should look like. So 2 marks if you meet both criteria. I would say if you have the mean in the right place, you get 1. And then there's the steepness, right? Which one is steeper, which one is flatter or higher and lower? That is another mark, right? That's determined by standard deviation. Use the mean and standard deviation of Toronto to determine a z-score of an income of 20,000. So remember, we had a 20,000 earlier for Winnipeg. That z-score was minus 1.67. Here we're at minus 1.6. I want to take this opportunity to talk about that. What is this telling us? It's telling us that in Winnipeg, technically, it puts you in, you're compared to the rest, you're making less yet than in Toronto, okay? So you're further away from the mean. How's that? You're further away from the average in Winnipeg with 20,000 than you are in Toronto. Okay. Determine the income with a z-score of 2.24 in Toronto. You plug that in, and so a z-score of 2.24 in Toronto would be the equivalent of 116,000 a year. Okay. Hey, there's a blast from the past, eh? Write the equation with a vertex of this, 2 x-intercepts, and is wide. 2 x-intercepts tells you that the sign of A and the sign of K should be different, right? If you want two x-intercepts. The sign of the x value of the vertex changes, right, when it comes in here. I'd say this gets a full mark. It being wide just means it has to be something between 0 and 1. And the sign matching, like having opposite signs, would be another half a mark. Okay, so half a mark for A being correct, and then signs would also be half a mark. So if you have a negative and a positive, or a positive and a negative, you will have 2 x-intercepts. But this has to be plus 3.45. The y value stays the same, right? We're looking at this one here. This is the vertex form. The vertex tells us these are the coordinates of the vertex. Okay. Convert 30 kilometers an hour to miles per hour. 30 kilometers in 1 hour. 1 mile has this many kilometers, right? This cancels out here. You end up with miles per hour. It's 18.64. 1 mark for that. Okay. So this is 7 now. 7 marks for this page. And now let's go on to the second part of the second AC I gave you. And I'm curious to see how you did here. All right, so the average IQ is 100, standard deviation of 15. What percentage? That's the key word there, percentage of population would you expect to have an IQ lower than 85? So I use normal CDF. My low is minus a million, overkill, right? But as long as you have something very low here, you're fine. Then 85 is the, right, you go from here all the way to here. You want anything lower than 85, and that's the mean standard deviation, so you end up with 15.86%. 1 mark for that. What percentage of the population would you expect to have IQs between 90 and 120? Easier, right? Lower, upper. Mean standard deviation, multiply your answer by 100. 65.63% of the population you would expect to have an IQ between those two scores. What IQ would one have if only 40% of the population scored higher on the test? Okay, so here you have to watch out. Inverse norm. So I hope you understand that you have to use inverse norm here because you're given the percentage. 40% scored higher than you, or than this score that you're interested in. That means that we need to enter 60% into inverse norm. So that if you use 60%, you get 1 mark for sure. And then you would get another mark for actually getting the correct answer. Bottom line, if you used inverse norm, you get 1 out of 2, right? If you use inverse norm, if you put 0.4 in here, you lose 1 mark, right? You lose 1 mark, but just keep that in mind. Let me help you out here. I was thinking, how can I help you with this? Because sometimes it's hard to determine where is this, right? If it's 40%, right? If you have your curve and you think of it, it either has to be here or it has to be here, right? So 40 is either above it or 40 is below, but we know that the 40 is smaller compared to the rest of the curve, right? And then you got to ask yourself, where does it make more sense, to be here or to be here? Is it saying this score is higher than 40% of the scores? Is it saying that? Or is it saying that this score puts you in the top 40 or you're below 40% of the population, something like that, right? So that's kind of how I would try to interpret it or narrow it down if you're not sure where in the curve are you, right? Okay. Suppose that you were told that the heights of adult males are normally distributed. That means a lot to us. Mean standard deviation given. Okay. What proportion or percentage of males are between 72 and 73? You plug that in, you get 9.18%. That's a mark. What heights correspond to the point where 20% of all adult males are greater than this height? So the emphasis are they're greater, 20% are greater, are above you. So again, this question is giving you this, so you need to figure out the 80%. So that 0.8 is worth 1 mark, and using inverse norm is worth another mark. Okay, when you have to figure out what's to the left of the value, I give you a full mark for that. So maybe on a test or quiz, watch out for it. If it's only worth 1 mark, it's going to be probably just straightforward, just plug in what you have. If it's 2 marks, you should be careful. Okay. What height corresponds to a point where 20% of all adult males are less than this height? Right. So what point so that 20% are less than this height? So you're definitely here somewhere. In this case, it's just 0.2, 72, and so this is just a mark here. So let me help you out. So this is 1, 2, 3, 4, right? That's why it's worth 4 marks for this one. And let me check, 1, 2, 3, 4 as well for the top. So this is worth 8 in total for this page. Okay, backside. Here it is. The weight of chocolate bars has a mean of 8, standard deviation of 0.1. What is the weight of a chocolate bar with a z-score of negative 2.7? If you're given a z-score, chances are, right, and you do know the mean and you do know the standard deviation, so you just use this formula, plug it in, and you get 7.73 ounces. Okay, chocolate bars less than 7.75 ounces are rejected and not sold. If the factory produces 12,000 a day, how many of these are usable? Usable, they want it. So there are various ways of doing this. If you go percentage rejected, you go normal CDF, negative 10,000 to 7.75, right? You figure that out. So I figured out how many rejected bars there are, which is 75. Then I just subtract that from the 12,000 to say these are usable, right? Usable bars are 11,925. I hope that makes sense. Could you have done this a different way? You say yes. You could have done normal CDF, 7.75, all the way to a million or whatever, right? That would have given you the percentage of usable bars, and then you just go multiply that answer by 12,000. You would have gotten something in this neighborhood, right? And so show me the work, and you're probably going to get full marks, okay? Even if you're off by a little bit, show me the work, because I understand that depending on what you put into normal CDF, you might have slightly different percentages. Okay, you're tired already, right? Oh, how many marks do I get for this? You get 1 mark for this, and you would get 2 marks for coming up with this answer, because regardless of how you do it, you need 2 steps, right? So let's say 1 step for figuring out either rejected or usable percentage-wise, and then another mark for actually coming up with the number of, so 2 marks for that. And I know that I gave you a little bit too much today, I realize that, but I needed you to get your feet wet before the quiz, right? So here, A, right, find the mean and standard deviation first. 1 variable stats, L1, L2. So you find the midpoints. I'd give you a mark for the midpoints, okay? I'd give you a mark for having this figured out. Then I would give you another mark for figuring out the mean and the standard deviation. So you'd lose this mark for midpoints if you didn't do that. If I see that you're using L1 and L2, you'd still get this mark, okay? Which is gonna be different, obviously different. And now, what is it actually asking us? Determine the percentage of mothers who were older than 18. Older than 18. Sorry. Under, sorry. I need to get glasses. Under 18, sorry. So you're going negative 10,000 all the way to 18, because this is going to tell you everything up to 18, right? And then mean, standard deviation, multiply it by 100, you get 0.81% of mothers. This is very dated, so I don't know what it is now, but it's the, I guess, the steps that are, I should update that. I should. I won't worry about the bonus, because I'm going to teach you how to do that. So I'm not going to worry about that. If you figured it out, I'll show you, but I won't explain it. I don't know if you figured it out. If you did, way to go. Okay. What are we at here? Hold on. So I give you 1 mark for midpoints. Let's do this again. 1 mark for midpoints, 1 mark for mean standard deviation, and 1 mark for using normal CDF and figuring out this, which is going to be different if you get different answers here. That's okay. You still get this mark for step. Okay. So you may have lost 2 marks. If you didn't do midpoints and you don't show me that you're using L2, it may be -1, and but you still get this one. Okay. So please show me the L2, because if I don't know why you got that, I sometimes make a note on my key that if you forget L2, you get these numbers, then I figure it out. But sometimes I can't, right? So the backside here is therefore worth 6 marks up to the, like, just before the bonus. So we were 6 and 8, right? 6 and 8. That makes the second AC worth 14. Am I right? Yeah, 14. So let's just do separate marks, okay? So you do, the first one was worth 16. right? The first one was worth 16. Put a mark out of 16 on that one. The second one was worth 14. Just put a mark out of 14 on that one, and I'll enter it separately. Question? Okay, I'll come and see you. Before I come and see you, I just want to add something. What can you expect for the quiz tomorrow? Basically, everything we've done up until now, right? So everything we've done up until now is going to be on the quiz. I will give you the whole class to do the quiz. You know me, right? That's what I like to do. That's the one day where I don't want to cut you off. Sometimes on ACs I do that, right? And I'm sorry for that, but I have my time that I need to keep going. So and that puts me in a difficult spot, right? I need to teach a little bit more. So the deal is going to be you're going to have to watch a 30-minute video and fill in your notes. Come back when you come back on Thursday, okay? So if you're done the quiz early, any chance, you can start already in class. And then on Thursday, I would like you to have watched it for it to make sense, okay? 30 minutes. I'll keep it at 30 minutes. Thank you, guys.